We're going to go ahead and take a look at an application problem from section 10.4, which deals with graphs of quadratic functions. I'm going to go ahead and look at number 64 on page 735 of your textbook. If you don't have your textbook, please go ahead and pause the video and get that ready. Again, I'm on page 735, and I'm looking at number 64. Okay, so I'm going to read through the problem first, and then I'm going to start picking out vital information. So the cost, C, in dollars of operating a certain concrete cutting machine is related to the number of minutes, N. The machine is run by the function C of N is equal to 2.2 N squared minus 66N plus 655. For what number of minutes is the cost of running the machine a minimum? What is the minimum cost? So again, here, they said C is the cost, and the units that we're going to use, or the unit that we're going to use is dollars. N is going to be the number of minutes we run the machine. You are also given the function C of N is equal to 2.2 N squared minus 66N plus 655. So note here, the input, or the values that we would put into the function, are going to be your number of minutes. Okay, the output that we're going to get is going to be the cost. And this kind of makes sense, right? The longer that we would run the machine, so the longer we run the machine in terms of the number of minutes, the higher the cost it's going to be in order to run it. Okay, so the number of minutes that we run the machine is going to affect the cost that would come out of our pocket to run it. Okay, so one other thing that I want you to note is that the highest degree in this function is this 2. So what shape, if you were to graph this, what kind of shape do you think you would see? And maybe some of you are making that motion with your finger, or maybe you're sketching it on the sheet of paper in front of you, or maybe you're just saying it takes on the shape of a parabola, which is this U shape. Notice that the 2.2 that we have here is a positive 2.2. That's going to indicate that your function, or of your graph, is going to be opening upward. And again, to remind you, we want to find the minimum, the number of minutes, for what number of minutes is the cost of running the machine a minimum, and what is the minimum cost? Well, if you look at the graph, and again, this isn't perfect, we're just looking at the shape of it, the vertex is your minimum in this case. If I were to ask you to find a point that is lower than the vertex, you wouldn't be able to find one in this instance because everything after the vertex is slowly growing upward. Okay. So we have some tools in order to calculate the vertex. That's going to reveal the number of minutes, and then also from there we can find the minimum cost. So when we go ahead and do this, our input value, N, is going to be equal to that negative B over 2A formula that we have at our disposal. So we're going to go ahead and fill that in. My B is that negative 66, and my A is that 2.2. And you may need to access a calculator in this instance. So again, go ahead and make sure that you have that ready. When we go ahead and clean that up, this is going to be 66 all over 4.4. And then if we do the division, we'll find that this is 15 minutes. Okay, so we know how long we have to run the machine, but in order for us to spend the minimum or least amount of money. Okay. So since I know the number of minutes, I'm going to go ahead and put that into my function. So I'm going to plug a 15 in for my input value, or my input variable of n. So that's going to be equal to 2.2 times 15 squared minus 66 times 15 plus 655. And by doing this, we're going to go ahead and find out the cost. How much we're going to have to spend in order to run this machine for 15 minutes. Okay, so do this a few steps at a time, or I'm at least going to go ahead and do that. So here we have 2.2 times 15 squared, which is 225, minus 66 times 15, which gives us 990, plus 655. 2.2 times 225 is going to give us 495, minus 990, plus 655. And this comes out to $160. So we have all the information that we need. The first part of the question that was posed to us, for what number of minutes is the cost of running the machine a minimum, that would be your 15 minutes. And then what is the minimum cost? The minimum cost here is going to be $160. That means that any other amount of time that we use, or any number of minutes greater than 15 minutes, we're going to see a higher cost. Okay, so hopefully that was helpful.